Time to lock in, guys.
Okay, the key is you can see that the calendar is up there for the rest of the semester. As more events come up, I'll update the running list. Your senior stuff is down here in terms of field trips. The Chapter 2 exam. So we are in 2-3. We will finish 2-3 today. There's still 2-4 and 2-5. 2, I don't remember if it's 4 or 5, but one of them is like 2 to 3 days. I think it was 5, yeah. It's definitely a 2-day lesson. It might even be a 3-day lesson, depending on if we're understanding it. I don't see a way to have the Chapter 2 exam on Friday. I'll let you know for sure tomorrow, but it's not looking good. It looks like if we were, it would be rushed, and I don't know which would be better, to rush it and roll the dice, or to just stretch it out, and then when we come back, having it on like the 17th. I feel like the 17th would bode well for everyone's grades. I know that you're going to go over the break and not look at math at a certain point. I get it. You would have to, at some point, look at the math, though. I'm going to be zooming in from my vacation on the 10th. And then I'm going to be doing my homework, if my mom will let me not drive. I'm going to do my homework while she drives, because we're going on vacation as well. You've got to schedule it in like a doctor's appointment. Okay, that's part of college. So I think that's what we're going to end up doing. I'll let you know for sure tomorrow. But I feel like if we have the exam on Friday, it's going to be rushed. And there's no review day. You would have to review outside of class. You'd have to rely on flex. And there would be no actual day of where we're just reviewing and I can just walk around and answer questions.
Test grades will also.
I think so. I think the test grades would be lower than if we waited and stretched it to the 17th. But having said that, we are looking at 2-3 and we are finishing it today. While 2-3 is short, the material in 2-3 is heavy. So that's why 2-3 does take 2 days. On Friday, we refresh. So 2-3 starts with function composition, where you're composing a function within a function. And we learned that the way that it's written determines the order. Yeah. Order matters. If it's of x, it means your answer is just a formula with x in it. If it's of a number, it means you're actually plugging a number in and getting a number. We practiced this on Friday. You can even compose a function within a function, like within itself. You can do that. You have to just be careful with it. The worst part is domain and range, or well, just domain for this. We're not looking at range. Did anybody by chance practice the Desmos link? Nope. Okay, well, please try it. I can actually go in and see who has done it, so there's no sense in telling me, yeah, I did it, and then if I go check that, you didn't. Please try it, because I think it's going to help you to see the visual on the domains. Now, the link also includes range. We are not doing range right now. We're just doing domain, but it will help. I promise it'll help. On Friday, we talked about when you have to state the domain of the composition function, there are 2 parts to it. The first part is the actual function you get after you compose, and then the other part is whatever the innermost function is, you have to keep its domain in consideration. And then we practiced it by stacking them vertically and then writing whatever they had in common. Do you remember that? And then like g of f, if you compose g of f, you end up with the square root of x and then minus 3. So because that's an even root, that radicand has to stay greater than or equal to 0. So I copied the number line to say, okay, I'm allowed to plug 0 or anything higher in. Then you have to consider the innermost function, the function that comes after the word of, and what its domain is. Well, the function f, where is it? Is right here. It's the square root of x. So its domain is also 0 or higher. So I stacked both of them, and because they are identical, then my domain is exactly that. Now this up here shows you two different domains, and to get the actual answer, it's going to be whatever they have in common, which I shaded in yellow.
Isn't this just the same thing we did with the shading of the, like, on the graph?
It is.
Right?
It is. It's just now you have two of them. Yes. I think that's where we stopped. Yeah, we didn't. Yeah, we didn't. All right, hold on.
And that was
Stop.
Yeah. Behind my desk, on the white bookshelf.
Here you go.
All right. So go to this slide right here. I would like you, there's 4 parts here. First, find f of g, then find g of f, then find the domain of each of those. So there's 4 questions here. So let's organize. I would like you to, oh my word, why is this not? Okay, first says find f of g. F of g. Now, you can write it like that, or you can write it with the parentheses of x. Don't let that throw you off. It just means, hey, take function f and compose it with function g. If you remember from Friday, what did we say we write first? In this case, we write the function f first. So 1 over x minus 2. Then we beep out what?
X.
The x. So 1 over beep minus 2. And what goes in the beep? The function that is the innermost, which in this case is g, which is 5 over x. So this looks weird because you've got the big fraction, and then on the bottom you have a fraction minus 2. The only reason that this problem is challenging is because of the way we have to clean that up. That's what makes this problem challenging. That's the answer, but that's not the format that my math lab wants you, or that college expectations would expect of you. This would be lazy to leave it like this. You've got to clean it up. How do you clean it up? Well, first, you need this to be a single fraction. Right now, it's a fraction minus an entire whole part. We need it to just be one fraction. So you've got to go back to your basic rules from middle school when you're combining a fraction with a whole part. You need we're subtracting, so we need a common denominator. Well, the only denominator I have is x. So that means that this here needs to have what in the bottom? It needs to have an x in the bottom. So what would I multiply it by to get an x on the bottom? And why am I allowed to multiply by x over x? Because anything over itself is 1. So I'm basically multiplying this -2 by a big old fat fancy 1, but it's disguised as x over x, because now I can see that this is actually minus 2x over x. You with me? This is understood to be over 1. You just multiply straight across. So I have 5 over x minus 2x over x. See that? Now why do we do that? So that I can now write that as one fraction. They have a common denominator, so I can write this. I'm going to come right here next to it and say, or 1 over 5 minus 2x my board thinks we're on break already. All right, 5 minus 2x over x. Do you see what I did there? Don't lose sight of the whole point of this. The whole point was clean it up. While this might, well, it doesn't look cleaner, but we're closer. Now we have a giant fraction with a fraction in it, right? So we need to keep, change, flip. Very good. We need to keep, change, flip, which looks terrible if I write it like that. So you can write it on yours if you want. Just throw you in there, it looks bad. So keep the 1, change the division to multiplication, flip the fraction, and then of course 1 times anything is what? It's itself. So I'm just going to write a big or that. That's all we end up with. Right? Did I lose you? Okay. I don't really like that written over there, so I'm going to actually bring it back right here. So this is f of g. Now that's the only one that's challenging. I need y'all to find g of f. I'm going to let you look at it. I'm going to say no, and now I'm going to ask you why not. There's another reason why the x won't cancel.
The 5 doesn't have an x in it.
So on the bottom, because that's multiple terms, if you cancel anything, it's got to come out of every term that's surrounded by addition and subtraction signs. And so since the 5 doesn't have an x, then we can't do that. Y'all find g of f. It's not nearly as bad. Write function g, beep out the x, plug function f in, clean it up. Did you get 5x minus 10? So writing g, beeping the x out, plugging in f, and you should feel uncomfortable because you just put a fraction within a fraction, which tells you we need to keep, change, flip, and get it to just a single fraction. Now, you've got to keep in mind what you're keeping and flipping. Remember what it started as. It started as 5 over beep. So the 5 is what you keep. The over, the division bar is what you change to multiplication. and on bottom is what's flipping. So this would be 5 multiplied by, now if I flip it, it looks like this. But don't get caught up in when you flip it. Like, what are you actually working with? I'm working with a binomial divided by 1. What's anything divided by 1? It's itself. So that's the same thing as 5 times x minus 2, which is 5x minus 10.
I have a question.
Yeah.
What about the denominator? So you know how you flip the denominator x minus 2 over 1?
Yeah.
The original has a, you multiply it by its original, so it do whatever x minus 2. So why would the x minus 2?
Why are you multiplying by the original?
No, like it's flipped.
Oh, it'd be x minus 2 over 1 if you flip it.
Right. So
Okay.
if it was in the top.
So the denominator is 1, which means you can erase it. This 1 in the bottom is understood. It's ugly at first until you keep change flip. Then it's pretty. That's a 5 over 1 times x minus 2 over 1, so the 1s are null and void.
And then the x minus 2 over 1 bottom.
It's a binomial. It's not on the bottom. There's no x minus 2 on the bottom. We don't need common denominators here. We needed common denominators over here because this was a fraction minus a whole part, and we needed it to become a single fraction, so we had to get a common denominator. This is already a single fraction. So once you have just a single fraction there, you can keep change flipping. I couldn't flip this yet because they were not connected. You know, you had a fraction minus the whole part, they're not connected. So I had to get a common denominator to a single fraction, then I could keep change flipping. Okay, so that's finding the functions. Now it's everyone's favorite part, stating the domains. So remember, for the domain, you need a visual of the domain of the actual composed function, and then you need a visual of the domain of the innermost function. So if we're doing the domain of f of g, right, then I need the domain of the function f of g and of just g, because g is the innermost. Guys, these domain questions revolve around the same thing every time. Every time. Okay? You've got, it's basically multiple choice. So you got a 25% chance to get it right. What are the multiple choice options? Well, all real numbers is one of them, right? If it's a fraction, the denominator cannot be 0, so it would be the entire number line except skipping over whatever would make the bottom 0. If it's an even root, the radicand can never be negative. So it's radicand greater than or equal to 0, and you would solve that to figure out what your restriction is. And if the small chance that comes up is when it's an even root in the bottom of the fraction, then you just take off the or equal to. So you have 4 types of choices for domain. How do you know which one you're dealing with? You have to look at the function. Is it a fraction? Is it an even root? Does it have an even root in the bottom of the fraction? Or is it other? Linear, quadratic, cubic? That's it. Okay? So look at what we're working with. F of g is right here. It's a fraction. Okay, so the bottom cannot be 0. It cannot be 0. So set it equal to 0 and solve and see what's off limits. So I would subtract 5 and then divide by -2. I have very little room here, so I'm doing this in my head. So I would have negative 5 divided by negative 2, what's off limits? 5 over 2 is off limits, right? You don't see that, then solve it. I've run out of room. You subtract the 5, you divide by the negative 2. You know how my math lab is. They don't want decimals, they want fractions. I personally would say 2.5 is off limits, but my math lab wants it as 5 over 2. Now look at just G, and the reason we're only looking at G is because it was the innermost one. Where is it? What's G? 5 over x. It's a fraction. G is 5 over x, so what can x not be? 0. So your domain here is all real numbers, but you better skip over, go in order. Which one would come first if I was reading left to right? I'd skip over 0, and then I'd skip over 5 over 2. So here's what it would look like as a visual. 0's here, 5 over 2. My gosh, my throat, my screen's shaking. Okay, quit. So, oh Lord. No, it's just like when you're standing right here so close to it, I feel like my whole head is just shaking. So it's all numbers possible, but can't have 0, can't have 5 over 2. So then you would represent that in interval notation from left to right, and it would be, how many shaded regions do you have? You have 3 shaded regions, so you're going to have 3 intervals. So read it left to right. This is going to be negative infinity, skip 0, 0 to 5 over 2, skipping that, then 5 over 2, comma, to infinity. Now this next one's not so bad because look at the function that we came to. Now we're doing the domain of g of f. So we've got to talk about the function g of f. This is what we came to. What is it? It's linear because it's x to the first power. Linear is not one of our 3 watch out. So it's all real numbers. So this one is anything. Now let's look at the innermost, f. What's the function for f? Look at the function for f. What is it? It's a fraction. What would make the bottom 0 there? 2. Might even help to come up here and say to yourself, okay, so for this, x cannot be 2. For this one, we said x cannot be 0. It might be helpful to do that right underneath them so you'll keep it in mind. So we're going to copy that x cannot be 2, which would mean the entire number line, but when you get to 2, you would skip over it. Right? Now, so what is the actual domain? You're looking for what they have in common. So it's what? Negative infinity to 2, skip, go to infinity. It's what they have in common. So it's whichever one is the most restrictive is your answer, or if you have to put restrictions together. But if 2 is off limits in f, then 2 cannot be plugged into g of f. All right, 3 slides left. The next 2 slides, it's called decomposing. So this is the reverse. Which you might think, oh Lord, I'm struggling with going forward, Ms. Holcombe. How are you going to make me go in reverse? This one's actually not bad. You do need to let me clear that. You do need to look at it and think about a puzzle, okay? Hey, Aubrey, Mr. Trevilian said, can you come down? I mean, I'm teaching, so.
No, it's not me.
I want to leave.
I want a savings class. This is a fun class. Brody's just being mean.
Brody just bullies her because he's insecure.
I'm not sure.
Oh,
Y'all
my.
are friends, aren't you?
Yeah, okay.
No.
Are we friends, Brody?
This is the day. Yeah.
Look at this slide right here. We're decomposing, okay? So this is where you got to understand what would I be plugging into in order to get my final answer. So look at it. If h of x is parentheses 2x minus 3 raised to the 5th power, it says find functions f and g such that, meaning they're telling you what you're working with. They're saying that h of x is, if I close that, f of g of x, right? They're telling you that the function, look how you read it, the function h is what you get after you compose f of g. And they want you to find f and g. Meaning, tell me what the function f would be and what the function g would be, so that if I composed it within each other, I would end up with 2x minus 3 raised to the 5th power. You see that? Okay, so if you have a highlighter, it would really help. Get a highlighter if you need one. I think once I show you this with a highlighter, you're going to be like, oh, that was not nearly as fast.
Thank you. Very tasty.
Anyone else need a highlighter? Anyone else?
Yeah, just keep looking at that football schedule. Ted.
Auburn has a bye week next week.
Ah, I told him to keep looking at that football schedule.
All right.
Maybe
What did they tell me that function h is? Like, what is it? What is the formula for function h?
2x minus 3
Okay, so I'm just going to write it. H of x
To
is
the 5th power.
2x minus 3
to the 5th power.
raised to the 5th power. All I've done is copied it, right? And it comes from composing f of g, correct? What's my input function? Input means the innermost one. Based on this order, which one's the input? Okay, I want you to draw a line or like some type of bracket, and I want you to make a note that this is the input, which means which function got plugged in? G, right? G's getting plugged into which one? F. F. All right. You're going to find the input first. Once you find the input, the other function should fall into place. Okay? You also should know that there are sometimes multiple correct answers here. So I'm going to talk to you about how they're going to test it on My Math Lab. But you should know that there's multiple right answers when you're doing decomposition of functions. Let me tell you what I always do. I like to think smarter, not harder. I always look at it and say to myself, what does it look like got plugged in? My mind immediately sees 2x minus 3 because it's surrounded by parentheses. So I'm imagining 2x minus 3 got plugged in to a function, right? Okay, if 2x minus 3 gets plugged in, what did it get plugged into? What? Yes. Read it as the beep. Once you highlight the input, read it as a beep. So it got plugged into beep to the 5th power. That beep is x. Okay? So watch how we write this out. So what's hard about decomposing functions is there's no like algebraic way to say step 1, step 2, and then you write it all out. It's literally
You were just getting old.
I don't even know. I was about to get excited. It's literally, it's almost like one of those mind maps where you're just blotting stuff down and you're thinking in your head. But I'm going to say if the input is 2x minus 3, then f of x would be beep to the 5th power, which means it would be x to the 5th power. I got that by simply highlighting the linear part and then trying to blur the linear out and say to myself, what is it getting plugged into? It's getting plugged into x to the 5th. Okay? That's it. Now, how is my math lab going to check you on this? Because there's multiple right answers, it's multiple choice. They're going to say answer choice A, like f of x is x to the 5th. G of x would be 2x minus 3. Answer choice B, it might say x, and then this might say 2x minus 3 parentheses to the 5th. You would have to know which one makes sense, which one looks like it got plugged in. And you can check it because you already know how to do f of g. You can check it with what you just ran off of. We just ran off of function. Let's see. Where's f? F is x to the 5th. So write the function f first. Right? Beep the x out. So beep. Now you can see where I was talking about the beep. I think of it as the beep. And then plug in function g, 2x minus 3. And does that match what they told me? Yes. So you did it right. So you can check it. Try the next one. There's 2 right answers on the next one. I tend to make my input linear, and my output, or not output, but my second function is what's left. I tend to make my input linear, my second function would be what's left. So look at it, find the linear, assign that as your input, and then write what would be left as the other function. So go into your problem. We've got h of x equals 1 over parentheses x plus 3 cubed. Take your highlighter, highlight the linear part. What's the linear part? X plus 3. Then blur it out in your mind and read the function without saying the linear part. I see 1 over to to the third power. There's your other function. So if, what do they ask for? How's it composed? It's f of g. So this is the input. So if g is the linear x plus 3, then f would be then you'd read it and beep out the highlighted part. I see 1 over beep cubed. You see that? That's not the only right answer, but that's the one that my mind saw. There was one other possibility. You might see, since it's a fraction, you might see 1 over beep, the whole thing, right? You might assign function g you might say function g is the entire denominator. You could say that. You could say it's the entire denominator, and then in that case, function f would just be 1 over x. Because it'd be 1 over beep, and then in the beep you would put x plus 3 cubed. That would still give you this. So there's two possible answers there. Here's what it looks like on my math lab. Here's an example. They want you to find functions f and g. You can see how they arrange the answer choices. I would not try to convince yourself which one works. I would just look and see how have they organized it. You'll notice that this is linear, linear. This is quadratic, quadratic. So then I would go to the problem and say, okay, if g is linear, x minus 8, then f would be, or whatever it's called, 3 over x squared. Then look, it's the very first one. You see how I got that? You know it's not this one. It can't be this one. Because it says over x cubed. The function is beep squared. So you know it's not that one. So that's how they check you on my math lab. All right, one slide left. I've already lost some of y'all. All right, here we go. A blouse, a shirt. A shirt that is size X in Japan is size S of X in the US, where S of X is X minus 3. A shirt that is size X in the US is size T of X in Australia, where T of X is X plus 4. Here's our source. Find a function that will convert blouses in Japan to blouses in Australia. Okay, well, I know when you first read this, you're probably going to get a headache. Then when you read it a second time, because Ms. Holcombe told you to read them twice, you're going to mark out what's not needed, and there's really not a lot of fluff here. Then you're going to take notes on what you just read. Let's take notes. What did they say is in the function for in the U.S.? In the U.S., what was the function? S of X equals X minus 3. What was the function for Australia? Then you have to ask yourself, what have we been doing this whole section? Function composition. We're clearly fixing to do function composition. I know that the word problems are everyone's least favorite, but if it falls in a section where you've only covered one thing, the word problem involves the one thing, okay? So keep that in mind as you're trying to answer the word problem. Now, what do you notice is the input for both of them? What's the input? X. So that's good. We don't have two totally different inputs here. Australia is already in terms of X. United States is already in terms of X. Now let's remind ourselves what the goal was. The goal was what? A function converting from what to what? We're going from Japan to Australia, right? Did they give us any way to go straight from Japan to Australia? No. How does the problem read? It starts with what? It's x in Japan.
To
Do a visual.
S of X.
And then it's s of x. Where?
US.
In the U.S.
To T of X.
Then it goes to t of x in Australia. The t of x right here is coming from what country? Right immediately? It's coming from
US.
the U.S. So this is, instead of t of x, because it's coming from the U.S., it's t of s of x, which is what we just did, function composition. We're not used to seeing it with parentheses. We did the little O. This is the goal right here. That's the goal. That one. That is the same thing as this. T of S. It is. I agree. You wouldn't know how to do it unless you already worked through one, probably. But now you work through one, so when you come to it, you should know how to do it. It'll be the same. So we're going to write which one first?
T.
T. T was x plus 4. Then I'm going to beep out the x. So beep plus 4. In the beep, I'm going to put what? I'm putting function s, which is x minus 3. Then I clean it up, and what do I get?
X plus 1.
Yep.